Okay, so here is another lesson on the quotient rule, which is we'll look at the rule and then we'll look at some examples. So the rule is this a to the n power over a to the n power. And the effect of that is if I have the bases are the same and I have an exponent with a different exponent in the denominator, then we would subtract them. So why? Well, if we go back to kind of the expanded form version, right, we can see that thinking to this first example, I have how many 3's in the numerator? I have 1, 2, 3, 4, 5. And how many 3's in the denominator? I have 2. So anything in the numerator and denominator, they just cross cancel, right? Because anything divided by itself is 1, right? Again, this would cross cancel, they'd be 1, and I'd just be left with these 3 3's in the numerator, which is just repeated multiplication, so it's 3 to the third. And if I look, I have 5 minus 2, which will give me that 3. So I can rewrite this right here. Instead of expanded form, I can think of it as just the rule, which is m minus n. This exponent minus this exponent, as long as the bases are the same. Well, then we can apply that logic over here. We can say x to the fourth, but minus what? Again, there's no exponent, but there's always an exponent on a value. It's just not present, which means it must be 1. So we subtract, which gives us x to the third power. And so these are kind of the low-level ideas, but they're when I say low level, it doesn't mean they don't have a lot of influence and a lot of effects as you move through the math. So let's look at this one over here. I have this coefficient and I have this coefficient down here, so these are just numbers that we would multiply after we did whatever work we did to that work. But let's look. We have this x to the second here, and if I just don't think about the 4 and the 3 for a moment, I'll come back to them. Just look at these variables. So let's group the things that we see that are alike. This will help us kind of see that we can just kind of navigate these things independently, and I'm adding the 1 there because it should be there. Even though they're all here, I can group them in the same way because, again, parentheses just means multiplication. When there was nothing, it's multiplication. So, look, I have the same thing here. I have x squared on top, x squared on bottom. So, again, we know that if it's the same on both, they cancel out. So I'm just left with these 4 to 3, but then I have this 3 minus 1, and again, I can just go back to the idea of 3 minus 1, so it's 2. So I'm left with just 4 over 3, and then the y to the second, because I'd have 3 minus 1. Over here, this is kind of a bigger effective understanding concept. So this is where most of the difficulty begins to occur. Most of the students will get this and this idea conceptually, but then this one they'll run into a little difficulty, but then this one many students just can't do because of a lot of the conceptual ideas. Although they can, it's just they make errors. It takes a bit of practice. So again, we have to add a 1 exponent where there is none. So all the variables have exponents, but these two numbers here do not. But they deserve 1 because, again, 2 has an exponent of 1. It's just imaginary. So we're going to do the same thing we did. We're going to distribute just like we did in the last situation. So we're actually integrating multiple rules at the same time here. And I'm just showing you I am distributing that 2 to all 8 exponents. And when I do that, I get 2 to the second, right? H to the 12th. I get J to the 16th, K to the 6th, all over 4 to the second, H to the 4th, J to the 3rd, K to the 4th. Okay. Oh, I've made a mistake here. I forgot to multiply this J down here. J to the 6th. Yes, mistakes happen, right? But you got to pay attention, and you can correct those, no problem. It's real time, and those things happen in real time. So we end up with simplifying this. We end up with simplifying the 4 on the bottom, and then we can apply this 12 minus 4, right? Because again, we can kind of break up the variables so they're separate, and I can just look at them by themselves. And so 12 minus 4 is 8, so I have h to the 8th, and then I have 16 minus 6, so I would have, let me make this look better, I would have j to the 10th, and then 6 minus 4, I would have k to the 2nd. And of course, I am finished, but it's best practice if you can simplify coefficients. Always do it. It's just it's neater, and it's kind of lazy not to. it's not always required, but it's best practice. So 4/16 just simplifies to 1/4. And then because there is no other denominator, I can put all of these exponents with the variable terms or values inside the expression alongside it, because the coefficient just means to multiply. So that is the quotient rule.